All right, so I'm still stick, so we'll see how this goes, but this is going from radical form to exponential form and vice versa. So if we start with something in exponential form, we can write it in radical form. What happens is on the radical, the bottom of your fraction is going to be the number that's out in front. The only number we don't write there is a 2 because that's just assumed. So this would look like an n on the front, and then we can write it one of two ways. We can do the root first. Normally you want to do this with high numbers, or we can do the power first. So we could take x to the m and then do the root of whatever n is. Okay, so two options. They are both correct if we're just rewriting. It doesn't matter the form. So for your examples, we had x to the 1/6, and we were writing it in radical form. So the bottom number goes on front of the radical, or the radicand. So that would be a 6. The x would stay, and then we would have just a first power, which we never write. So it would just look like that. The second one is going backwards. So we have the 4th root of x. So we would write that. I'm just going to move my camera over a little bit. We would write that as x to the power of 1 over the root of 4. So x to the 1/4 power. Okay, if we look at the third one, we would write x to the 1/5. This isn't working. Sorry, I have a tripod that I'm trying out. It's not working very well. So we would have the 1/5. So again, the bottom comes out in front. The power goes on that exponent. Again, if it's a 1, you do not have to write it. We'll have 1 here in a minute that's not a 1. We have x to the 8th root. We're writing it exponentially, so it has a power of 1 technically. So 1 over 8 would be our exponential form. All right. Okay, getting into a little bit more difficult ones. So I'm just going to get rid of that. Okay, so we have 5. We have x to the 7/4. We're writing it in radical form. So we are going to take the root of the bottom, so that's the 4th, and then the power of 7. So again, you could write it one of two different ways, but this one we do have to reduce. So when we reduce it, doing the same as we did yesterday, 7 divided by 4, we have a solid 1 that can come out. Okay, really you're doing your elementary school division, multiply, subtract, and we get a remainder of 3. So that is what's going to stay on the inside. So that would be our answer. All right, 6 is a little bit difficult, not difficult, different. We have the cubed root of x to the -5th. We're trying to get into exponential form. Okay, so what we're going to do is we are going to write our power of -5 over our root of 3. And then we're not allowed to have negative exponents just like we weren't right before break. So all that's going to happen is we put a 1 on top, and then x becomes to the positive 5/3. Okay, exponential, so we can leave it just like that. All right. Then we have a little bit, again, a little bit more difficult. Number 7, we have x to the 1/4 times x to the 9/4, sorry. Okay, so they are product of like bases. So law of exponents says that we can add the exponents. So we'd have 1/4 plus 9/4, which gives us 10/4. We can reduce that to 5/2. So we have x to the 5/2 is really what we have. And then most likely, since we're in exponential form, it would have asked us to go into radical. So we would change, okay. Since it's a 2 on the bottom, we don't write the 2 on front of the exponent, just like we don't write the exponent of 1. We don't write the radical with a 2 in the front. Power of 5. So again, imaginary 2, positive 5 on the inside. So we would have to go one step further in breaking down. Elementary school division. How many times does 2 go into 5? 2, with a remainder of 1. So we have an exponent of 2 on the outside and 1 on the inside. Again, we don't have to write that power of 1. So that is your answer. All right, and then the most fun one of the day was number 8. Okay, so we had the 4th root of 27. over the square root of 3. So we did it differently in class. I'm going to do it the easiest way, which is to try to get them to be like bases. So the first thing I'm going to do is break down 27 into 3 and 9, and then 9's going to break down into 3 and 3. Okay, then I'm going to rewrite this. Okay, there's 3 3s, so that's a power of 3. You can't see that. Okay, so I'm going to rewrite it as 3 cubed to the 4th root, and then I can rewrite that further to 3 to the 3/4. Okay, I'm going to do the same thing with the bottom. So I'm going to have 3 to the 3/4 on the top over 3 to the 1/2, okay, which is just the square root. And then this is quotient of like bases. So all we do is subtract the fractions. So in this case, 3/4 is bigger than 1/2. So I'm going to take my 1/2 from 3/4. I'm going to get rid of that bottom because I'm subtracting the exponent to get rid of it. I need the like denominator, so I'm going to make 1/2 into 2/4. I subtract 3 minus 2, gives me a 1. Bottom stays, so we end up with 1/4, which you could probably leave it like that, or you can write it as the 4th root. Okay, so those were our notes. Okay, and I'm going to go over a couple from our homework as well. All right. So actually, maybe I should make a new video. So I'm going to pause and make a new video.